In this video, I'll demonstrate passing objects as arguments to functions, once as a reference parameter and then as a value parameter. Now, in our program, we have function f1 defined in line 4. Return type is void. Function f1 receives a circle parameter by reference, and the name of this parameter is PC. And the circle PC calls up the setRadius function and sets the radius to 44. Now in the main function, we declare a circle object, C2, set the radius to 5.5. We'll print the value of the radius in line 18, and then call up the function f1 and send C2 as an argument. Now, since this is a call by reference, C2 and the parameter PC are the same. PC is an alias for the parameter C2. So when the value of the radius in PC is changed to 44, that carries over to C2, and the value of C2 is also changed to 44. To verify that, we'll call up the getRadius in the main function and to see whether the radius has changed from 5.5 to 44. So we'll run this. And see what the output is, and that is correct. Initially, the radius was 5.5, then C2 was passed by reference to function f1. F1 changed the value of the radius, and that change was permanent. It carried over to C2. And that's called by reference, basically. Now, to demonstrate call by value, we have the function f2 defined in line 9. Again, the return type is void. This function f2 receives a parameter of the type circle, but it's a value parameter. There's no ampersand next to this circle. This is a value parameter. The name of this parameter again is PC, and PC calls setRadius function and changes the value of radius to 44. In the main function again, we'll have the circle C2. It's created with radius 5.5. We'll print the value of radius in C2 and then call function f2 this time around. Now, since this time around f2 receives the circle parameter by value, a copy of C2 is sent over to the function f2, not the actual object. So we are dealing with two different objects. PC in the function f2 is really a copy of the original. So the changes that are made in f2 function are changes that are made to the copy, not the original object. So in this case, when the call is returned and we print out the value of C2, the value of the radius in C2, we notice that the radius has not changed. So let's try this. There you go. And the value of radius before call and after call in both cases remain to be 5.5. Now, a call by reference is much more efficient than a call by value, because in a call by reference, the address in the memory of the object is sent to the function. So in that respect, it's more efficient. But it's not secure, because the function can change the value of data members of the object. On the other hand, call by value is less efficient, but it's more secure, because the function is only working on a copy of the original object. So whatever changes are made to the copy will not carry over to the original object. Now you may ask, is there an option where I can benefit from the efficiency of call by reference and security of call by value? And yes, there is. I'm going to copy this second function and paste it here just to demonstrate this third option. We'll call it function F3. This will make the parameter a reference parameter. So I'll place the ampersand in there to make it a reference parameter. But what we can do is to turn it into a constant reference parameter. Right? If we do this, then the parameter PC is passed by reference, which is efficient, but we made it constant, meaning that this function is not allowed to change anything in the function. Notice that the setRadius call, we have a kind of compiler flag right here telling us that you're not allowed to do this. Basically, you can't change the value of radius in PC. So this is, and you see a lot of functions in C++ have parameters as constant reference type parameter. And this is the situation where you're basically taking advantage of efficiency of call by reference, but security of call by value. But you got to make sure that inside the body of the function, you're not trying to change any of the values of the data member of the parameter, because the compiler will flag you and will produce an error.